If we want to avoid our cats barking and our humans to abduct aliens, we need to know how the type system handles variance. And in this video, I'm going to give you a short overview what variance is. This is going to be a bit technical, I'm sorry, but it's important. And we'll then do a small case study on how Typescript handles variance. And finally, I'll also show you how we can get a human to try to abduct an alien. So what is variance? Variance refers to the input and output typings of our functions, or rather their substitution behavior. Let's look at this function, for example. It's just a callback function that takes a callback. And the central question of variance is, what types are we allowed to put in here? Let's look at our types first. We have creatures, we have aliens, which are subtypes of creatures. We have earthlings, which are also subtypes of creature, and we have humans, which are a type of earthling. And we have multiple different functions. One that is from earth to earth, one from creature to creature, one from human to human, one from human to creature, and one from creature to human. Now, which one of these are valid parameters for callback earth to earth? Well, earth to earth is probably valid. We don't get an error here. Now, can we substitute creature to creature? In Typescript, we can't. Which makes sense, because if we wanted to call, let's say, a function that only earthlings have, on the return type of this function, a creature wouldn't have this. So this function here that returns a creature would lead to a runtime error. Can we put an argument of human to human in there? Which we can't also do that, because if the callback earth to earth function would be creating a earthling and try to call this function with an earthling that isn't a human, and this callback function here tries to call a function on a human, like the function itself, then we'd also run into a runtime error. So can we put in a human to creature? We also can't put a human to creature. It's basically the combination of both of these. But we can put in a creature to human, because every human, every earthling will have the same interface as a creature. So the argument here can be substituted with creature. And every human will have all functions an earthling has. So we can substitute it here. And that is what variance means. We can substitute our human. We can substitute our earthlings with a human. That is what we call covariant. And we can substitute our earthling with a creature, which is what we call contravariant. So in Typescript, functions are contravariant in their parameters and covariant in their return types. That's all good and fine, but what about containers, not just functions? Let's say we have a few lists here, a list of creatures, a list of earthlings, a list of aliens, and a list of humans. Now, can we assign to human earthlings? No, we can't. Because if we tried to index into the human array here, we'd expect a human and we'd have the same issue. We'd call a function on a human that doesn't exist because it's not a human if we put in earthlings here. Now, are they covariant? Yes, they are. And that is how we get to our problem that I mentioned in the beginning. Because creatures are also mutable. So, what we can do is we can push into our humans here, which pretends to be an array of creatures, our alien. And if we similarly do this to our spaceship, we declare it as type of creatures, we assign alien to it, and then we can push a human into it. But that also mutates the original alien array, because it's a mutable one. This would be perfectly fine if it's immutable. And now we can try to call from our aliens, which Typescript tells us is of type alien, safely the function abduct on a human, which should be a human according to Typescript, but it's actually not. If we switch to the browser, I've copied over the relevant part down here. If I zoom in, oh, it doesn't like zooming that much in. If I run this now, yeah, sorry. Then we see that aliens1 abduct is not a function. That is because aliens1 is not a human. It's not an alien. If we look at our aliens here, that is after the mutation, we see that we have the human named Johnny in here. That is part of the humans array. And our humans contain an alien in the index number 1, but in the second position. So Typescript is actually not completely type-safe in regards to mutable containers, like arrays. Let's formally discuss the variance types. If we read this as A is a subtype of B, and this is A is equal to the type of B, and this is whatever the type is after we apply F, then invariant means the type before and after is the same. Covariant means the type ordering stays the same. So after the assignment, the subtype of f of A is also a subtype of f of B. Contra is the reverse. That is, we flip the ordering. Variant means it's one or the other. Bivariant is it's actually both afterwards, which there isn't really a good example in Typescript for it, and it's not that easy to find a good example for it. The most common types of variants are these three here. The other two are a bit more exotic and at least in Typescript also harder to find. Fun fact, Typescript had bivariant functions in the past, but it doesn't have it anymore. If you've got any questions or want me to take a look at something, leave a comment or join my Discord. It's in the description. And see you around.